Let's talk about determining zeros and the multiplicities of zeros. This video is really meant to help you clarify some of the vocabulary that can be confusing. The values of x in the domain of f of x, for which f of x is equal to 0, are called the zeros of the function. Now remember, f of x is just a fancy way of writing y. So essentially, if we're setting y equal to 0 and then solving, the results are going to be the zeros of the function. These are the real solutions, which are also called the roots, of the equation f of x is equal to 0, and they correspond to the x-intercepts of the graph. So it's easier to explain this if we look at an old example, because we've already looked at a lot of different quadratic functions, so let's circle back to those to see if this vocabulary makes sense. So for f of x equals x squared plus 2x minus 15, if we're trying to find the zeros, then we're basically setting f of x equal to 0, meaning we're setting y equal to 0, and then we're going to solve this resulting equation. Now this is a quadratic equation, it's degree 2, so we can solve it by factoring, or we could try to do the quadratic formula. But as always, I want you to try to factor first, because that's going to be more efficient than using the quadratic formula. Little review here. Remember, the leading coefficient here is a 1. So we essentially just need to find two numbers that are going to multiply together to give me this c value, which in this case is negative 15. And then we need the same two numbers to add together to give you the b value. In this case, that is positive 2. So two numbers that multiply to give us negative 15, but the same two numbers add to give us positive 2. And that, of course, will be a positive 5 times a negative 3, and then a positive 5 plus a negative 3. So our factored form will be x plus 5 and x minus 3. And again, always check that. Check the outside. X times negative 3 is negative 3x. 5 times x is just 5x. And sure enough, 5x plus a negative 3x will give us a positive 2x. We always want to check our factoring and make sure that it works. So once we have this factored, then we're going to use that zero product property where we're going to set each of our factors equal to 0. So either x plus 5 is equal to 0 or x minus 3 equals 0. And we end up with x equals negative 5 and x equals positive 3. So the zeros of this function would be negative 5 and positive 3. But remember, because we found these values by setting y equal to 0, that means that these correspond to the x-intercepts on the graph. So the x-intercepts would be the points negative 5, 0, because y is equal to 0, and 3, 0, which of course then helps you sketch a quick graph. So a little just review here. If we were to go ahead and plot the two x-intercepts, one is at negative 5, 0, and one is at positive 3, 0. And then because this is a polynomial which is degree 2, we know the graph will be a parabola. It's a polynomial that's going to open up because the leading coefficient is a 1. And of course, we could do a bunch of work to find the vertex if we wanted to, but I'm not going to go to that length, and I'm just going to do a little rough sketch here just as a reminder. So the zeros in this case are negative 5 and positive 3. The real zeros correspond to the x-intercepts on the graph. Now in the next set of videos, we're going to talk about the multiplicities of the zeros. In this case, in this example, we had zeros of negative 5 and positive 3, but these zeros only appeared one time. And when we take a look at the graph, you'll notice that at the 0 of negative 5, that x-intercept, the graph just crosses straight through the x-axis. Same thing here at positive 3, the graph just crosses straight through the x-axis. And that has to do with the fact that these two zeros only appeared one time. We didn't end up with a multiplicity. But again, we're going to dive deeper into that in the following videos.